Hi everyone, this is your favorite chemistry teacher, Miss Park. This video is for our asynchronous assignment on Wednesday, May 12th. This is the independent practice for the stoichiometry problems. So let's go right into it. So I posted the resources here. We have the notes that we worked on last week, and then also the answer key to Monday's assignment. So hopefully those two things help you to get started, to help you set up these equations for stoichiometry. If not, you're watching this video, I'm gonna go over problem number 1 and 2 here. All right, so problem number 1. Here is a mole-to-mole problem. All right, so we're trying to convert 1 mole that's given in the problem to another mole, another compound, okay? So here is our given equation. Remember, I call this the recipe. And the question is asking if 4.3 moles of Na2S sodium sulfide are used in the reaction, how many moles of Al2S3, which is aluminum sulfide, are produced? Okay, so I gave you some notes here, step by step to convert mole to mole. And our first step is to identify the given moles. And hopefully that's the easiest part, right? It's right here. We are given 4.3 moles of Na2S, which is sodium sulfide. So right, 4.3 mole Na2S. And now our second step is to set up a mole ratio between the unknown and the given, right? And you look for that in the problem. Okay, I've said this a million times, right? Our unknown is what are we solving for in this problem, right? And the given is the given moles, okay? So our unknown, if I read the problem again here, is if 4.3 moles of sodium sulfide are used in the reaction, how many moles of Al2S3 are produced? Here's what we're looking for, right? That's our unknown. That's what we're solving for. So let's look for that compound in our recipe, in our equation. And I see it right here, right? And some of you might be like, there's no coefficient, Miss Park. What do I put? What number is there? And if there's no coefficient, we assume that there's a 1 there, right? So I'll mark it right here. There's a 1 here. So that means that's our unknown. So that goes on top, right? I'll do it in yellow. So 1 Al2S3 is our unknown. That's what we're solving for. So we put that on top. And our given from the problem is moles of Na2S. Let's look for that in the equation. Here it is. So I'm gonna put that in on the bottom. So that gives us a mole ratio between aluminum sulfide and sodium sulfide. And notice when you set up the problem, right, you're gonna see that the units, right, on top, Na2S and bottom, they cancel each other out because they're on top and bottom, right? So the remaining units are moles Al2S3, and that is exactly what we're solving for. So let's plug this into the calculator. I have my phone calculator. Here, I'm gonna do 4.3 times 1 divided by 3. So you just need to do divided by 3, and I got 1.43. 1.43 0.43 mole Al2S3. That is my answer for number 1. Let's go to problem number 2. And here is a mole to mass problem. Right? We did mole to mole for problem number 1. And now we're doing a mole to mass. So we're converting mole into mass. And notice, let's read the problem. It says if 4.3 moles of Na2S are used in the reaction, how many moles of Al2S3 are produced? And that sounds very familiar, right? It's the same sentence as the first problem. And I just ask you, how many grams is that? And I gave you guys a hint here. I said, okay, so you guys have the answer to this from problem number 1, right? We solved for moles of Al2S3 on problem number 1, which was this. So I'm gonna go ahead and put that number in my first box here, 1.43 mole Al2S3. That's the first step. So I did the first step here. Our second step here is find the molar mass of Al2S3 because we want to convert moles into grams, right? Because we're asked to solve for grams. So we need the molar mass of aluminum sulfide. So I'm going to go to the periodic table and look for Al and S, right? Aluminum. So let's go to the periodic table. Aluminum is 26.982. Sulfur is S right here, 32.06. Just gonna change my color. Remember, we're not done with this. We need to now multiply each of the elements by their subscript, right? So it's Al2, so we're gonna multiply by 2, and S by 3. I'll zoom into this. So let's do that quickly. 26.982 times 2 equals, I got 53.964. 32.06 times 3, I get 96.18. And finally, we're just going to add these numbers to get our total mass. I get 150.144 grams per mole. Don't forget units. Grams per mole is our units for molar mass. So there it is, molar mass of Al2S3. We're gonna put it up here, 150.144 grams per mole, right? G per mole, that line, that fraction line also means per, like this. So once you set this up, now it's just a multiplication problem. Notice, I want you guys to notice that the units that cancel out is mole, right? Mole is on top and bottom. So our final answer is grams, 1.43. So I'm gonna do 1.43 times 150.144. I get 214.705. So I'm just gonna round that to 71. 214.71 grams, right? Here's my unit, grams of Al2S3. That is my final answer. All right, so I just went over problem number 1 and 2 in this video. I want you guys to do problem 3 and 4. And then also some of you for my honors, you're gonna go up to number 5. Note, you guys are gonna notice number 3 and number 4, they're the same exact setup as number 1 and 2. So you're gonna follow the same steps that I just showed you guys. But you just need to read the question, okay? You have to base it on the question that's given. All right, so good luck with these problems. We'll go over them in class tomorrow. But thanks for watching. Bye, guys.